Hello, folks. When people think of Tesla, they think of cars and maybe autonomous vehicles. But hidden inside is a $1 trillion energy business almost no one understands. Today, we're breaking down Tesla's energy business and the value it adds to the company and its shareholders in 2026 and beyond. Here are the details. All right. So, once again, just want to remind everybody that we have this massive bias in the mind of society and professional Wall Street analysts, especially the automotive analysts that cover Tesla, where they're stuck in this paradigm of thinking of it as a car company. And what we're going to see today in their energy business is it's really going to open up our eyes to this idea that it's not really a car company, okay? It's more like a, computer type company. So, like a Silicon Valley type company at its core. So, first of all, we need to define a term from the field of economics to help us understand what's going on here. It's called economies of scope. And economies of scope exist when the simultaneous production of multiple products at a lower cost or higher quality than if a firm made each product separately. Okay? And economies of scope happen in companies like Procter and Gamble when they can use their same core marketing team in order to market different products. With Disney, in which their creative team of writers and filmmakers, etc., can create characters that can then be repurposed and used for businesses such as television, uh, toys, okay, theme parks, etc. So they're reusing that same core competency over multiple products. And Alphabet, are also known as Google, for Google Search, YouTube with YouTube Search, Android operating system for phones. So they're repurposing their same computer science type of core competency over multiple product categories. So, first of all, why is electrical energy so important? Electrical energy is fundamental to any modern economy. Okay. In other words, the GDP of an economy is highly correlated with how much electrical energy that economy generates every year. And over here, you can see a little graph that I made that shows the total amount of electricity production of China over the past 10 years compared to the United States. And it's no coincidence that China has had a large GDP growth rate over the past 10 years, and its electricity production has really catapulted higher. And the United States has had a much lower GDP growth rate, somewhere around 2% over the past 10 years. And our electricity production capability has barely increased over that period. In other words, it's a fallacy to think that we can have tremendous growth in GDP by just conserving electricity better. And electrical energy conservation is a good thing, and you can get benefits from, in a sense, switching from, for example, incandescent light bulbs to fluorescence, and then fluorescence over to LEDs and stuff like that. But as a general rule, if you're going to really grow an economy, you have to produce more electricity. And electricity demand and the requirements for electricity in the United States and worldwide is just skyrocketing. Many people are calling this an electrical energy super cycle, driven by the demand from AI data centers, which require gigawatts of electricity at this point. Um, Electric vehicles, the electrification of transportation, reshoring of manufacturing, okay, bringing back all that the manufacturing capability to the United States. All those plants need a lot of electricity. The Build Back Better tax bill that just went into effect recently, there's 100% um, capital investment deduction that companies are able to take, this year. So the amount of growth in capital investment, factories, AI data centers, etc., in the United States is just exploding the demand for electricity. Permitting in the United States is very, very difficult and time consuming. Lots of environmental requirements tied into this, so it's difficult to get new plants built. And there's a general sense amongst people in most communities in the United States of not in my backyard. They don't want electrical energy power plants in their towns, in their neighborhoods. Okay, so these things are holding back the supply of electricity. So somehow we need the electricity. We have to have it. How do we get it? Tesla is solving this problem. And just in terms of time alone, uh, it's about 4 years from design, from start until completion of a natural gas powered power plant in the United States, and 7 years for a coal plant if you can even get it built, and nuclear. I mean, it could be decades. And then one last data point that kind of points out how you know explosive the demand is for electricity right now. Here's a graph of the Next Power, used to be called Next Tracker, solar power, um, grid scale solar power company. And you can see that the stock price has increased by, what, 200% over the past year. And over here, we have a graph showing the GE Vernova company, which is one of the three mega producers of natural gas fired electrical generation plants. And the stock price on that has just exploded higher over the past year as well. So both on the renewable side and on the fossil fuel side, the demand for electrical energy generation is just exploding right now. So, the Tesla Energy Division, which most people have no idea even exists, leverages the incredibly intelligent design capability of their 4680 lithium ion battery cells. Okay, so they design these wonderful lithium ion battery cells for their electric cars. Okay, and they can repurpose, and they are repurposing the same technology for solving numerous important energy problems for society. And so this falls into the category of what economists call economies of scope. So they have several products that use this. One is the Mega Pack. Okay, these are gigantic grid scale energy storage um, solutions. And over here we can see an image that shows what these things look like. Each of these huge boxes here is about the size of an intermodal shipping container. And they're, basically designed to be very easily driven on a flatbed semi truck out to, from the factory out to wherever it's needed, and just kind of like set these things down on the ground and plug them in, and they are ready to do their job. And then they also have, for home-based energy solution, they have a power wall. So this is kind of like a cabinet that's filled with these 4680 cells, and there's some electronics and power inverters and software that automatically reads and detects like when the electrical energy needs to be fed into the system and whether when it needs to be fed out of the system. And uh, you know, once you study Tesla a little bit, you realize how important it is for, for Elon Musk to have control over the whole system. So it's a vertically integrated business. They have lithium refining. So they're taking the raw lithium ore from the earth and they're turning it into, the product that's needed to go into these battery cells. So not only do they design and build the battery cells, but they make the packs. They assemble the cells into these big packs, and they have silicon integrated chips that go with it that help regulate the power going in and out. And of course, the software that runs on those chips that feeds the electricity in and out of these things. So a couple case studies on how these are used. One is for grid scale fossil fuel electric utility. Let's say typical electric utility. It has maybe a coal plant and maybe one or two gas-fired plants. And over here we can see a graph that shows the electrical energy demand on the vertical axis and the hour of the day on the horizontal. And this shows the demand for electricity that typically occurs as we go through the day. And you can see obviously at 3 o'clock in the morning when nobody really needs to have their lights on, the demand for electricity is quite low. But here we have about 5, 6 p.m. people coming home from work. They're washing clothes. They're turning on maybe electric ovens, air conditioners, appliances. We get a peak demand for electricity at this time, and then of course it falls off as people turn their lights off and go to bed. So how can we make these electric grids more efficient? One way that we can make them more efficient is if we could figure out a way to store the electrical energy during these, low demand periods, okay? Take and produce energy during the low demand periods and add it in to the demand during the high demand periods, during the peak periods, okay? And there's been a number of different technologies that have been designed to do this. In the 1970s, I think it was in 1971, in Ludington, Michigan, my home state, they built this giant water reservoir. And here we have Lake Michigan. And the way this works is during low energy demand period, when electricity prices are very low, they pump water way, way up. This is actually like hundreds of feet up in the air. It's kind of like tucked on top of a series of sand dunes. It's very crazy type of design. It's like a lake that's sitting on top of all these sand dunes here. They must line it you know, with clay or something, or some sort of liner in order to keep it from leaking out. And then when they need the electricity, they let the water flow through these turbines, which turn and generate electricity, and it feeds the energy into the grid. But it's not a very efficient system because there's energy loss when you pump it up into this reservoir, and then there's also energy loss when you convert the potential energy of the water back into electrical energy when it goes through the turbines. There's turbulent flow resistance and heat and there's also evaporation of water that can occur. So I think it's about 75% efficient in terms of the energy that goes in versus the energy that goes out. Whereas these large Tesla mega packs are about 95% efficient. So 95% of the energy goes in, 95, 100, energy goes in, 95% of that energy comes back out. Another use case, solar, wind, and battery systems. So here we have a large solar farm. Obviously, solar, you're only generating electricity during the day. So the idea is that, hey, take the energy that's produced during the day, store it in these megapacks, and then feed the electricity from the megapacks out into the grid, in the evening and at night when the sun is not shining. And same idea with wind farms, okay? Store it in batteries when it's windy on windy days, and then you feed it into the grid on days when the wind is not blowing so hard. All right, another hugely growing importance use case for these mega packs is for AI, large language model training purposes. So when you're training a large language model, there's these tremendous spikes in energy demand as the AI model is massively parallel processing in these GPUs. And so it's almost impossible to manage the proper flow in and out of an AI data center once you get up to hundreds of thousands of uh, GPUs in a single data center cluster. And so by pairing the megapacks to the AI data centers, then it can smooth out and the spikes in demand of electricity, and it, in a sense, tames those power spikes that come. It also helps by pairing these mega packs to the AI data centers. It helps speeds up the deployment of the AI data training center so you can put your AI data training center up faster. And it reduces the overall operating costs because you can, in a sense, draw energy from the grid during the middle of the night when electricity prices are low. And then you can feed the electricity into your AI data center during the more expensive early evening peak periods of the day. So recently, Tesla, this is January 28th, actually, they released their fourth quarter 2025 earnings report. And down here, I found their energy, um, their, their energy business deployed units and units of gigawatt hours of these mega packs and power walls. And you can see in 2021, it was 4 gigawatt hours, and then it went up to 6.5. And then in 2025, they deployed 46.7 gigawatt hours of worth of these energy products. And if you compare that to 2024, which was 31.4, it's a 49% year over year increase in deployments. So it's just exploding demand for this type of product. Um, their energy division as a percent of total revenue for the company is going up. It's increasingly important. Their energy division revenue, as you can see, is gone from a little over $2 billion a year in 2021, and we're up around 12 in 2025, and this trend is just going to continue. So I've done a little back of the envelope calculation on what I think the value of their energy division business will be going forward, and it seems to me that there's a pretty clear runway for them to generate about 75 billion in revenue by 2030, and they have about a 30% profit margin on this type of product. And with the type of growth that they have, it would be easy, I think, for them to assign a price earnings multiple of about 50 to this type of business. So that gives you a $1.1 trillion in market cap value for this business. And the total market cap for Tesla, their car business, their their autonomous, full self-driving software business, robo-taxi business, all the other stuff, the Optimus, it's all adds up to 1.6. So you have just the energy component of their business, which is something that a traditional auto analyst probably doesn't even understand, um, is worth almost as much as the whole company is worth today. Okay. So, yeah, I've done a couple videos on Tesla, and you can tell that I'm pretty excited about the opportunities going forward. I wanted to share this with everyone. This is top of funnel, and you need to talk this type of investment over with your own financial advisor. Um, because my risk tolerance is different than yours, but I see the potential for Tesla over the next 5 years to be incredibly bright. All right. And this energy business thing is to me worth almost as much as the whole company is worth today. So until next time, I'm Jeff Whitaker. Take care, everybody.